up to now we have completed the different types of responses present in a input output relation. So starting with this topic, that step response of RC circuit, it's a first order circuit. Okay, so first of all, draw the circuit. This is RC circuit. I'm including the initial conditions also. So what is happening? This is the circuit, this is R, this is a capacitor. If we want to draw the equivalent of capacitor including initial condition, we will introduce a voltage source, and there is a capacitor C. This is what step response means. Input is what? Step signal, that is I am taking Vs plus minus, this is R. This is what? This is initial voltage. I am writing it Vc0 minus. Is it okay? And this one is what? C. Okay, and this voltage is what? I've already told you that VCT means the voltage including the initial condition also. This is known as what? That is the voltage across the capacitor. Now its Laplace domain model will look like plus minus. This one is R, this one is voltage, this one is capacitor. We have already derived such type of equivalent circuits. This one is R. This is what? Constant voltage Vc0 minus by S. This is 1 by SC. This one is what? VCS. This one is R. This current is what? ICS. This was what? ICT. Is it okay? And this one is step function. The Laplace of a step is what? 1 by S, that is S. Is it okay? Now we have to derive the expression for VCT. So can I write here in this figure, VCS is equal to Vc0 minus divided by S, what? Plus ICS into 1 by SC. This loop. Is it okay? Now the ICS can be written as ICS is equal to this voltage minus this voltage divided by what? Divided by what? This and this one. Is it okay? Is it okay? So what I can write? Vs by S minus this voltage Vc0 minus divided by S divided by R plus 1 by SC. This is IC. Okay, now put this value into this expression. What I will get? VCS is equal to, I will get Vs by S plus, sorry, Vc0 minus by S plus what? Vs by S minus Vc0 minus by S divided by R plus 1 by SC. This is what? This is ICS multiplied by 1 by SC. Is it okay? Now let's do some simplification here. What I can do? Vc0 minus by S plus 1 by S bracket Vs minus V0, Vs minus Vc0 minus divided by SC R plus 1 by SC. Is it okay? Now we can make some more arrangement here. We can write it as Vc0 minus by S plus Vs minus Vc0 minus divided by, take this one, SRC bracket S plus 1 by RC. Is it okay? Is it okay? So can I write the complete thing in this manner? VCS is equal to Vs by S plus Vc0 minus Vs divided by S plus 1 by Rc. Is it okay? How I have written this? I have taken this one and make its partial fraction. I have got this amount. Is it okay? So now if we take the inverse Laplace, what I will get, Vct is equal to Vs plus what, Vc0 minus Vs e to the power minus t by Rc. Is it okay? This is the basic equation that we have to use always. Okay, now see, if we put t is equal to infinite in the above expression, what we will get, Vc infinite is equal to, this will be infinite, that means it will become 0. 0 means this is equal to Vs. So can I write this expression in this manner? Vct is equal to Vc infinite plus Vc0 minus Vc infinite, this is e to the power minus t by tau, is equal to Vc0 minus for t less than 0, and this one is for what, t greater than 0. Is it okay? Where tau is what, time constant, Rc, time constant. Is it okay? So this is the complete response what you will get from a RC circuit including initial conditions. Is it okay? Now if someone is asking different types of responses existing in this expression, what I can say, if someone is asking the steady state response will be, then steady state response will be, you can see from here, that is equal to Vs only, that is the permanent part of the total response, and Vs can be written as what, Vc infinite. Is it okay? Similarly, if someone is asking transient state response, then transient means which will die out at t is equal to infinite, that is equal to this one. So transient response will be Vc0 minus Vs bracket e to the power minus t by Rc. Next one, if someone is asking that what is the forced response, then what is the meaning of force? That is only due to what, the supply voltage and initial condition must be equal to 0. So can I write the whole expression Vct is equal to Vcnt plus Vcft, where Vcnt means the natural response, and this will be, you can see from here, natural response is always defined with respect to only initial conditions. Then make it 0, Vs will be 0. What will happen? This will be Vc0 minus e to the power minus t by what, Rc. Similarly, the forced response means what, when initial conditions are 0, if this one is 0, what you will get, Vs bracket 1 minus e to the power minus t by Rc. So this one is forced response and that one is what, natural response. Is it okay? So now I'm going to make some some cases in this system. What will be, the first case is what, that I'm going to discuss, that is what, that is case first. What is case first? See, this is case first. Case first is what, natural response Rc or source free response of Rc, what will be? So see here, natural Vct, I have already defined Vcnt, that is equal to, that is only due to the initial condition Vc0 minus e to the power minus t by what, tau. Is it okay? Let assume Vc0 minus is equal to how much? That is equal to V0. So we can write Vcnt, that is equal to V0 e to the power minus t by tau. Is it okay? So now see, if this is the voltage expression, what is the current expression for the capacitor? ICNT is equal to, we know that C dVCNT divided by what? dt. Is it okay? This, if you do the differentiation d by dt, V0 e to the power minus t by tau, and tau you know how much, that is RC. If you do this differentiation, you will get ICNT is equal to minus V0 by R into e to the power minus t by tau. Is it okay? So if somewhere there is no source is present and you have to find the response, then there will exist only natural response where the voltage will be V0 e to the power minus t by tau and the current will be minus V0 by R into e to the power minus t by tau. Now if you want to represent this graphically, then Vcnt is equal to V0 e to the power minus t by tau. It is exponentially decaying term. Initial voltage will be V0 and it will be decaying in nature. This is what? Tau. Similarly, if you want to draw for current, what we will get? This is T, this is ICNT. What I will get? Initial value will be, that is equal to minus of V0 by R, then exponentially it will rise to at this position. Is it okay? This is the graphical representation of the natural and forced responses, where tau is what? Tau is equal to what? RC, time constant, and it is defined as, the time taken by the response to reach 36.8% of initial value. Is it okay? So if it is tau, then what is this value? This will be 36.6% of what? V0. Okay, this is what the case first. Now I am moving forward for case 2. What is case 2? This is case 2. I am talking about forced response. It means I am going to calculate only the response due to the supply voltage. So what will that will be VCFT, that is force response, is only due to the supply voltage, and we have calculated Vs 1 minus e to the power minus t by tau. Is it okay? So now the current ICFT is equal to C dVCFT divided by what? dt. If you do this, C d by dt, Vs 1 minus e to the power minus t by tau, where tau is equal to what? RC. If you do this, what you will get? You will get Vs by R into e to the power minus t by what? Tau. This is 1 and this one is what? 2. So now represent this graphically. What will happen? This is VCFT, forced response. The initial value will be 0. Put it 0 here. If it is 0, this will be 1. 1 minus 1 is equal to 0. That will be 0. Then just make some more. T is 2, 3, 4, 5 seconds, and t is equal to infinite. At t is equal to infinite, if I will put, this will become 0 and this will become Vs. So this will Vs. I can say that this response will look like this. Is it okay? Similarly, if I want to draw the current, how it will look like? ICFT, this is T, this is what? initial, this is 0, 0 means t is 0, that is this one Vs by R, this is Vs by R, and after that it is exponentially decaying component you will get. Is it okay? So if I want to represent case third, that is the total response of the system that is due to the initial and supply both, then we can write VCT will be VCFT plus what? VCNT. Is it okay? So this will be, similarly ICT can be written as ICFT plus what? ICNT. Is it okay? Now graphically, if you want to represent, add up both responses. This is VCT. VCT will be the summation of VCFT and VCNT. VCFT is this one. VCNT is what? This one. Add up both. If you add up, what you will get? You will get this response like this, V0, like this. Is it okay? This one is what? Vs. Similarly, if I want to get a current response, ICT, what I will get? This is CFT. CFT is like this, and CNT is what? That was like this. This is Vs by R, and this that one was what? That one was what? Minus V0 by R. Is it okay? So just make these two combinations and you will get the complete response of the system. So this is the all about for what? This is for RC, first order RC circuits. So we have learned a basic expression for this case, and we will move forward in the same manner. Now coming to the solution points, problem based on RC circuits, what approach we should apply to get an accurate answer always. So I'm going to discuss this with you. So first point is what? First one, this is the steps to follow to solve problems based on first order RC circuit. Never bother about that it is a source free or with sources, and you have to remember different formulas for all that. Don't ever try all these things. Just always try to develop a general approach what you can apply in any type of problem which is based on RC circuits. But the limitation is what? It's only valid only for the first order circuit. If the order of the circuit is not first, then you don't ever try to apply such kind of approaches. In the basic section in sessions, I have told you that the best approach is what? That is the nodal analysis. So similarly for RC circuit, this is the best approach what you can try if the order of the circuit is what? That is only one. So step one is what? Step one is what? Write down the general expression what we have developed right now. VCT is equal to VC infinite plus VC0 minus VC infinite e to the power minus t by tau. This is for t greater than 0. Is it okay? Is equal to VC0 minus, this is for what? For t less than 0, or simply t is equal to 0 minus. Is it okay? This is the first step. Step 2 is to find the values of VC infinite and VC0 minus. VC0 minus means it has to be evaluated before switching. before switching means T is less than 0 by making capacitor as a open circuit. Similarly, VC infinite, it has to be evaluated after the switching. After switching, that means T must greater than 0 by making again capacitor is what? Open circuit. This is the step number 2. Now the step 3 is what? Finding the time constant. Finding the time constant. Tau is equal to RTH into C equivalent. RTH into C equivalent. And it is always calculated for T greater than 0, or we can say that it is always calculated for after switching phenomena, not before the switching phenomena. Please remember this point. Okay, so when you will calculate RTH, then what you have to consider, this is known as Thevenin resistance. Thevenin resistance seen by considering capacitor as load. While calculating the RTH, consider the capacitor as a load and find the Thevenin resistance. C equivalent means it is equivalent capacitance seen by considering resistors as load. So while calculating RTH and C equivalent, when RTH, then take it capacitor as a load. When calculating C equivalent, take resistor as a load. During the calculation of RTH and C equivalent, all independent sources must be deactivated. This is very important point. And all the basics what we have learned to calculate the RTH, I have already told that there are 3 possible cases: case 1, case 2 and case 3, and how to calculate the RTH for all those. In the same manner you will calculate the RTH here also. Now the step 4 is what? Put the values of step 2 and 3 in step 1. In step 1 we will get the final value of what? VCT. Okay, now the last step is 5. If in the question some other responses has been asked except VCT, then they use the above calculated value of VCT. You have to, then after you have to calculate the VCT first, then use the value of VCT in step 4 and apply the KVL and KCL nodal elements etc. to get your desired response in the network. So whenever VCT is not asked, another parameter is asked in the system, then first calculate the value of VCT, then apply in the system KVL, KCL, nodal and mesh etc. to get your desired response. So this is all about for first order RC circuit, and in the next session we will do some practice problems, some problems based on the RC circuits. So thank you very much. We will discuss the problems in the next lecture.